In this video we summarize our paper, Annotating Traversable Gaps in Walkable Environments. The planning of high-quality paths in complex 3D environments is becoming increasingly important, with applications such as crowd simulation, autonomous robots, event planning and games. Planning paths in 3D environments typically requires the generation of a navigation mesh, which needs a representation of the walkable areas as input. Consider the following example 3D environment. To determine the parts that an agent can walk on, we can remove all areas that are too steep or don't have enough vertical clearance, shown here in red. Unfortunately, this leaves us with a series of disconnected steps, and agents will not be able to navigate the stairs successfully. We present a method that tries to solve this problem by filling such gaps, shown here in green. We will illustrate how our algorithm works on this example input. We assume that steep and low vertical clearance parts have already been filtered out in a pre-processing step. We start by identifying cycles of boundary edges. In this example there are 3 such cycles, shown here in red. We then detect gaps between edges of different cycles. After all such gaps have been found, we heuristically select a set of non-overlapping gaps from these. Our heuristic is based on the horizontal distance between the connected edges. In this example, this gap is selected. We then detect gaps between edges in the same cycle of boundary edges. Instead of selecting a subset heuristically, here we project all gaps to the ground plane and take their union. After this, we lift the result back to the full 3D space. Note that this only works when the cycle forms a simple polygon after projection. In this example, the result is a complete filling of the hole. In the final step, we combine all the results and fill the detected gaps with triangles. The maximum allowable gap size can be configured with our algorithm, allowing us to smoothly fill holes up to the desired size. In our paper, we compare our algorithm to a voxel-based method called Recast. Consider this environment containing a 2-story house. Recast does a good job of capturing the available space and the connectivity between the 2 floors via the stairs, but the result is quite coarse and information about steps is lost. Our method accurately captures the walkable areas and the traversable gaps. We retain the information about all gaps and steps in the environment, which can be useful for animation and path planning systems. However, it should be noted that our algorithm is currently orders of magnitude slower than Recast. Thank you for watching, and please come to our booth if you have any questions or would like to know more.